lite nervös, men annars är allting bra. Det ska man väl vara. Ja.
Nej, vi har en ljudtekniker där uppe som sköter det.
Det här rummet bredvid, vilket håll är det?
Växlar du över eller? Ja. Nej. Du. $2.5 quillion bytes of data, or 2.5 times 10 raised to 18 bytes of data. That's what we in the globe produce of data every day. And you can also see that in the last 2 years, we have produced 90% of all data that we have here on the globe. So with that, welcome to SICS Open House. I'm Ingrid Nordmark, the CEO of SICS, and started here in August. And this is really something I have been looking forward to. So in the beginning of May, The Economist had this article. The world's most valuable resources is no longer oil, but data. And what they bring up is the most valuable companies in the world right now is Amazon, Apple, Facebook, Google, and Microsoft. And what do they have in common? All of them have data as the core in their business model. And I think all of you have read the newspaper that Tesla is worth more than GM right now. In Q1, they sold 25,000 cars. GM sold almost 100 times more, 2.3 million cars. And still the market see that Tesla is coming. They increase the value with the data they got, then they train the car to drive better every day. So what have brought us here? It's really that's the technology start to get mature. We have cloud, one joint infrastructure, Internet of Things. We could collect all this data. The big data analytics, we could analyze everything. And this is where we have been at SICS since we started for more than 30 years, doing research in all these areas. And now we could see it's really taking off right now. But looking ahead to come even further, we have to do even more research in AI, security. And what I think is really crucial is really software engineering. Software design, test, verification, to get these technologies to all kind of companies. And that brings us to why we are a research institute. Why are we here? We are now, since last time if you were here, we are now fully owned by the government. And in the bill from the Ministry of Enterprise and Innovation, they say that we should enable sustainable growth in Sweden with world-leading technology. That's something to start today with. Sustainable growth. How should we do that, and how should we interpret that? For me, I'm going back to the definition. What is sustainability? That has three aspects. It's the environmental, social, and economic. And what's really happened is really that we have this digitalization in our society. So what I see is that we should work for sustainable digitalization in Sweden. That's what I take from this bill from the government. And what are we doing there? Let's start with environmental. I picked up 3 examples. The first, green IoT. In Uppsala, we are putting up a lot of sensors so they could measure the air pollution. And we drive for open APIs so that you could add whatever sensors you want and services, so we could scale it. And we also look so that you could have the data in an easy way so that you could act on the data. That's one thing. Uppsala, so number one, collect data in a really good open way. Number two, we have since many years worked with railway to optimize the timetable, to optimize resources. Doing that with Trafikverket. That's a complicated thing to put the timetable for trains. And I think this is really good because here it comes. If you have used all complex math models, we are able to optimize this to another level. And with doing that, we can move trucks from the roads to the railways, using that in a much, much more efficient way. And we as person could have less delays, hopefully, as well, if we have better timetables. And in Västervik, we have just started to build up a test bed for drones. And that is with focus on environmental and agriculture usage. So, for example, you could have with sensors measure exact amount of fertilization, and then you don't have too much, and you don't get this into the groundwater. So this is an example how we could use our research to get better environmental. Let's go for social. Can you just close your eyes? Try to find your mobile and think of making a telephone call. You can open your eyes now. It's pretty complicated. I take this example because my mother got a serious eye disease 2 years ago. So now she has lost her site completely. And from being full active, baking the best buns in the world, reading the latest books, completely doing everything by herself. In 2 years, she's not even capable to do a telephone call by herself. And for me, being in this world, knowing about this technology they have, it has been a wake up. The technology is not mature enough to be used for people that really need it. But I talk with the mother and say, before she turns 90, she's 83 now, I'm sure that she will have her own little robot that's bring the phone to her, and she could speak with it and say, hello, I want to speak with Ingrid. And that's what I see we can do. We can do it, but it's not out there. We are doing a lot of projects in these areas. One where we have had really good result is one of is chronic diseases, COPD. It's a lung disease, KOL in Swedish. They cost a lot, and so that's why we got to do this project. So what we're doing is that the patients gets in control of their own health. They measure their values by themselves, this data as we spoke about. They send it to the lung clinic with one button. They have video calls with the specialist at the hospitals every day, and they are in control. And what we're doing is bring all different specialists together to bring this to life. And after running that, we see people feel so much better because they are in control. They have a self-esteem back. And we, as taxpayer, is saving a lot as well. The last one in sustainable digitalization is economical. Before I joined SICS, I have been in the industry, and I have been part of many different development in the research front end. I have seen a lot of good examples. I have seen a lot of lost opportunities because that there is no connection, not enough connection, should I say, between research and development, the market. But I can take one good example. When I worked at Ericsson 10 years ago as a development manager for LTE or 4G, we spend a lot of time together with the market unit to really understand what is key, what will make Ericsson successful. And I just put up one analog example. I talk so much of data and digitalization. So what we understood from the development is that the radio will be on a lot of different bands. So we will need a huge amount of different variants of radio. And that's hard to do radio, it's hard to test radio. So that we brought with us. We did the software architecture and moved away as much as possible of the intelligence from the radio to the main unit. So the radio was as stupid as possible. And then we look radio, that's hard to produce, it's hard to do variants. It's a new standard. So the key persons developing radio start to think. And they found a new way with a big innovation how to use the 3G radio. That was patented, and we have possibility to use that radio. And that meant that Ericsson was able to release the most variants in the world the first year with good quality. And that was really because we understood each other. We understood the market, we understood the possibility, what is really possible to do from a technology point of view. And this is really what I want us at SICS to do more of. Bring, as an independent part, bring this together. Bring this so that we really release all knowledge we have. And if you look at this picture again I started with, can you see some patterns? They are all American. We are smart as them. It's more that, as I see, we in this company, the one I know some friends and so on, I see a different attitude to research and development in board, in the highest management team. They see the value. They really use this data to build business. And that's I want us as be one enabler to do this. So now, if I hold my timetable, the world has been producing 26,000 quadrillion bytes of data. So we have our gold mine here. With that, I want to say thank you. And welcome the two moderators for today. Helena Järregård, that's CEO of Rise 6 in Västerås. And you have been there, 6 in Västerås has been around for 5 years, and with focus on the industry in the region, especially on automation. And you really bring the knowledge from research together. And I see a big need because you have raised from 0 to 37 million turnover last year. It's impressive. And Torbjörn Minde, CEO of Rise 6 North. You are building up a data center up in Luleå. I think you will be world famous in a couple of years. But because in just 1 year, you have a turnover for 70 million from 0. So you see, we have a big need for this research. So, welcome. I hand over to you.
Yes, thank you very much, Ingrid.
We have a great day in front of us. This morning seminars. We have 2 super guest speakers today. And after the coffee break, I hope they have switched the slide. No? Can you get the agenda up? Okay, maybe I should be the one pointing something. But now we have the agenda. So I'm happy. So we have a coffee break. So first 2 guest speakers and then coffee break. And after the coffee break, we have researchers from SICS presenting a lot of the latest and greatest. So it will be a very interesting morning. And I hand over to Helena that introduce the first.
Yeah. First, some also practical information.
Yes.
That is something that we always have to talk about, and that is emergency exits on both sides of the room.
And then you have to take it to the right.
Yeah, and also if you need to go to a restroom, it's also right out and then turn right. And
Yeah, you
go
have to
some
walk
steps.
a little bit
Yeah.
out there and
Yeah.
to the right.
Good. So that's the practical information. And also, maybe some of you have had thoughts about what are these glass vases standing here. And since Ingrid talked about the importance of sustainability, we will also have that focus on the seminars today. So we will talk about, you can hold the balls, yeah. Environmental, that is not green, it's blue today. We will talk about
Hydropower.
Yeah,
green.
hydropower, yes. We will talk about social, the heart, sustainability and economical sustainability. Okay, you put it in there. Yeah. So we will have that focus for today. And you can think about what will be the leading ones, because we will put them here to see what are the speakers focus most into. So maybe you have an idea and you can have a competition with yourself to see if you're winning or not. Okay, so now it's time to present our first speaker, and I have to have some note here. We're also sustainable because we're reusing our business cards now. As so, Sara Öhrvall, welcome up. We're really happy to have you back because you've been here. Yeah. Sara has been here before. I think it was like 5 years ago, something. Yeah. Then you were representative from Bonnier and the global R&D person there. And right now you're a senior advisor, you're a speaker, columnist, and also maker of things.
Yes.
Yeah. And you will talk about digital transformation for collective well-being today.
Yes.
Yeah.
Thank you.
Most welcome.
Thank you. Well, first, hello, nice to be here. And you're so many people standing. There are actually seats. Maybe you can help your friends and wave where there's seats if you want to sit. I see many of them over here. If you want to sit, maybe you want to stand up. There's seats there. All right. Digital transformation for collective well-being. That's a pretty pretentious headline, right? And I obviously don't have many answers, but I do have a number of questions. And I do think we need to start to discuss to a greater extent, because as we sort of are on the cusp of this major digital transformation, which has huge impacts on individuals, society, corporations, yet it doesn't seem like we have a whole of a society approach to this transformation. And since technology has no ethics, moral, and there's no guarantee that this transformation will be evenly distributed in terms of benefits, maybe it's about time that we do start to talk a little bit more about inclusive development. Now, I come from the corporate side, and I sit on a number of boards, so I guess my role is to speak about what's on top of the agenda on the in the corporate boardrooms. And I can assure you that this slide is definitely on top of everyone's agenda. This is the projection from Standard & Poor in terms of the average lifespan of corporations. And according to existing data, if you just extrapolate, then in 10 years, 75% of all of the major companies on this list will be gone. That's a pretty dramatic number. Now, these are US numbers, but Gartner has just posted the statement that during 2017, around the developed world, 20% of all market leaders will be taken over by a company that was founded at the year 2000 or later. 20% of all. So this is the speed of transformation, which is obviously changing a lot of things. And if we look at what's happened and the sort of patterns of these transformations, I do think there are a number of key learnings to talk about. And if you look at these companies and how they've changed markets, and you try to sort of define what happened, you see that so far, there is no industry that has transformed itself. None. All of them has been transformed by completely new entrants. And all of the existing companies have so far neglected to observe that change until it's too late, which is kind of interesting because by now it should be a pattern that's recognizable. But yet we sort of tend to forget that these are competitors, not new phenomena operating in another part of the business. Secondly, quite often these companies enter the market with minimum fixed assets. They find new ways of delivering their services. I'm on the board for Bisnode. Bisnode's major cost, the sort of where we spend most of our money, is to buy data. Bisnode buys data, repackage data, and sell data again. Now, if you compete with companies like Waze, who obviously, as you know, you all donate your data to Waze. Waze is zero cost in buying data, whereas Bisnode has their major cost there. Obviously, it's a pretty hard position. It's pretty hard to change to meet that competition. And as we know, many of these companies also work as platforms. They have distributed products and services, which means that the growth is exponential. When other companies start to deliver on top of their platform, the growth is quite astonishing. And then again, with low marginal cost. And all of these things combined makes it so hard for the existing corporations to just change their business model, the distribution model, because actually these new companies quite often operate like a thin layer on top of these vast supply systems. And on this thin layer, they meet millions and millions and millions of users, and therefore get all the data, which is, as we heard, the new oil. And so it continues. And if we look at this change, now we have Nicklas and Google in the room, so I'll be a bit careful. But it's just interesting to see the major growth, obviously, both in market value and in brand value. But if you also look at, which is maybe more important, I think, for the future, the R&D spending. If you look at the top 11 R&D spenders in the US markets, 5 of them will be these companies. And if you look at the M&A on top of that, you see that these companies are so smart and deliberate in their way of buying talent, buying new technology to continuously also improve their R&D efforts through M&A, which means, who knows, but the thinking power that's aggregated within this company is just growing and growing. And on top of that, they have all these third parties that are really dependent on their platform to do their services, which means that they have sort of built very strong positions. And maybe primarily, once again, these thin layers meet all these numbers of people, which means they get all the data, which the third-party providers do not have to the same extent. Now, my point is that the companies that I work with, they have a very hard time understanding how do we compete against this? When do we cooperate? When do we compete? How can we best sort of make an effort? And what do you do when you're in a small market, in a small language, when this is a global competition? And also the speed of change, because when these companies now try to become mobile first really hard, then this statement comes, no, sorry, we're now AI first, and then everything changes again quite quickly. And just to sort of give a picture on the knowledge, I don't know if you can see, but this has number of machine learning publications by Google, and maybe Nicklas can talk more about this, but it's quite impressive, like the research papers published by these companies. And in terms of AI, there were 140 AI companies bought by the big 5 technology platforms in the US since 2011. 140. 2 days ago, Apple bought another one for $200 million. There's a lot of knowledge gathered in these companies. And once again, with the companies that I work with, we're getting increasingly worried that we don't have this knowledge. We don't have this competence. And these are researchers, these are PhD, these are people with very, very specific and very valuable knowledge. And in Europe, we're very far from this situation, and it's becoming a worry. And it's not only about the US, because if we look at the Chinese big platform, we can see exactly the same growth, exactly the same situation, maybe even to a greater extent, dependent on what number you measure. So Baidu, Alibaba, Tencent, they all have the same approach. And if you look at Tencent specifically, they now have 250 researchers in their AI lab in Shenzhen, and they're building a similar one in Seattle. We don't have AI labs in the corporations in this country. Hardly any company has. And if we're becoming an AI first world, well, that's a serious problem. We have to find better ways to cooperate between corporations and research. So with that starting point, I just wanted to go through quickly 5 areas where I see companies that I work with that they have on top of mind right now, where they see a lot of change happening because the technology has such a huge impact on the business. And the first one is there, Zero UI. Because when Mark Zuckerberg says, as he did in April, that we're now going to build a computer-brain interface, and Apple buys Multi-tenant, that supposedly is capable to do the same thing. Well, that might be far away, but if we just look now at what's happening with voice interface, it's sort of the beginning of the same thing, that we can talk to technology or interact with technology in a way that does not involve a screen or a mobile phone. And from a business point of view, it means completely new ecosystems, completely new platforms to sell your services, completely new interfaces to all the products that you've developed, which is an enormous change. And I think this growth of Amazon Echo is so interesting, that if you look at that little system that is voice interaction, and the projected sales is now 20 million units in the US this year. They sold about 10 before, so 30 million households are now getting used to talking to technology, because that's what they do, right? They talk to some sort of pretty basic, but still AI bot in their home. That's going to change their expectations forever in terms of user interfaces and how to interact with technology. And if you look at the number of skills on that platform, so skills, as you know, it's the apps. So if Apple and Google calls it the apps on the mobile phone, Amazon calls it skills, but it's the same thing. Services on the Alexa platform. Last year, Q1, they had 1,000 skills, 30-party providers that deliver services on Alexa. This quarter, they had 10,000, a 10-fold increase of skills. It's just growing enormously because so many households are picking it up, and that means all these companies have to reinvent their interface. They have to define who are we when we're voice instead of a screen. That's interesting. Even more interesting is maybe what happens when AI is not one interface deliberately solving one thing, as I put up Amelia from IPsoft, which is now launched by the SEB Bank. She's called AIDA, but it's the same service. It's a customer service interface, a robot. If she's not solving one thing, but she's also the HR department in the company, because actually she knows exactly how this company is performing, and she can feed it back to HR and the performance reviews. And also, by the way, she can be the travel planner and the business support. She can be a lot of things in these companies. Right now, they're just solving one single thing. What happens when it's all intertwined? And what happens to organizations? What happens to workflows? What happens to a lot of things internally when we're getting there? And we're so close. Thirdly, a lot of discussions I have right now in the boardroom, it's about what do we do with all these possibilities to predict things with our data, when there's not only analytics that can describe what happens, but also what will happen, and also how can we make it happen, the prescriptive analytics. Because there are so many ethical questions in there, there's so many moral questions, there's so many legal questions, but yet the systems are there, and we see companies who are moving in this direction. And I don't know if you follow the dark ads placed by, supposedly placed by the Trump and his followers prior to the elections, where they managed to identify not only who will vote for Hillary, but why will they vote for Hillary, and what will make them change to vote for instead Trump. And once they found that, the prescriptive analytics, they could place ad individually targeted with misguiding information towards these individuals. Do we want that? Yes or no? But there are a lot of these questions because when the systems become that advanced, there are things we can do that we maybe don't even want to do, but it will deliver results. And there will be a lot of discussions in there. I have on the slide my colleague in Finland, Mariana. This is a pop-up that I have in my Gmail delivered by Crystal Knows. It gives me information about anyone that I'm meeting or mailing with. So I will get this pop-up saying we're 78% similar. How should I talk to her? What kind of language should I use? Should I be brief? Should I be detailed? Dependent on who she is, because this system analyzes our previous email conversation as well as social media. So it builds a profile of her, it builds a profile of our communication. Therefore, it guides me in terms of how I should interact with anyone I meet. It's not very smart, I should admit. It's not perfect, but it gives a sign of where we're heading. And what happens if every industry knows exactly who is walking into the store or meeting us at our websites or mobile interface? If we know exactly who they are and what they want, wouldn't we behave differently? Wouldn't we serve different services to different people if we can? And shouldn't we communicate differently if we know exactly who's in front of us? Moving on a little more quickly, obviously augmented reality just has huge potential. And I think primarily for industry, it's all about how to change the design process. How do you reinvent the whole prototyping part, the whole sort of collaboration part of the first design phase? But also, how do you change the service delivery when you have augmented reality? Because obviously you can send information to help people do things remotely. Like Wärtsilä, the Finnish shipbuilder, is experimenting with sending glasses out to the ships. So if the ship breaks down at the sea, the control tower in Finland could project data layers to guide the service technicians on how to repair at least some simple things instead of flying in people to do it. It's just an enormous difference in what kind of services you can deliver. And finally, of course, it's the service robots. And I saw this number now that in 2020, 60% of the service robots will be in Asia Pacific. And it is interesting to follow how these robots can be used as customer interface. Because first, we just saw them as something such as stupid, clunky machines. But when they powered with things like Crystal Knows, they will know exactly who will enter the store and what their needs are. Obviously, they will be pretty smart service employees. And how will that change things? Yes, so just a snapshot of thoughts that I think will have a tremendous impact on business moving forward. And therefore, there's a lot of need for knowledge and information in this area. And I just want to end up with a final thought about the third part that I see a lot of conversations going on right now, which is this increasing worry that how can we transform our society to be prepared for this change? And I just took this slide that you've seen this a million times, the World Economic Forum Networked Readiness Index, but I think we keep on saying, oh, we're number 3 in Sweden, but yet if we look at things like business and innovation, skills and government usage, we're really poor, actually. So if you break down these measurements, it seems like there are a number of areas where we're lacking behind quite seriously. And if we believe in all these sort of projections in terms of how work life is changing and automation is having an impact on our work life, we should be worried. This is the McKinsey numbers. You know, some say 50% of every job will be automated. McKinsey says that 60% of all work tasks can be automated to a third. In their projection is 2040. So they say 60% of all jobs have a 30% part of it that can be automated. So they have sort of, but it doesn't matter because obviously no one knows. But it happens. Exactly. And the other part of it, I think, which we also should discuss, this is a prediction from Forrester. We predict that CEOs will exit at least 30% of all their CMOs, their marketing directors, because they will not be capable of coping with all these new work tasks. So there's not only automation, it's all this sort of transformation of work skills that are needed. And obviously it scares people. And obviously we're gonna get into a situation where people are reluctant to adopt new technology because this is not a nice picture. And I think, therefore, it's so crucial that we have more positive images of where technology can take us. And this is, I love this movie, you might have seen it. It's from the Drive Me project in Gothenburg, and it's about, obviously, self-driving cars. But what's so interesting with this movie is that they've not focused on the technology in the cars, but instead what will change in our cities when we have autonomous cars. What would be the benefits for each and everyone? They can drive straight, so we can have more narrow streets, more space for people to walk on. We don't need as many parking spaces, so we can have parks, we can have great services, etc. My point is, we don't have that many visions about where technology can take us that has this whole of society approach. And unless we have that, I just think it's worrying that people feel just outside of this change. They don't feel like they're part of it, and they don't see how they will benefit. And I think this naive language is pretty nice too, to be honest. But there are so many areas where we don't have this vision. Health, what's the vision for health? How can it improve lives for everyone instead of people being scared of being part of a data system where people can see everything? Okay, I have to move on. I just want to make one more point, and that's about cities, because I think it's the same thing. This is a quote from MIT City Lab, but just the power of when we can measure everything, how we can change cities. And I jumped this slide and I just summarize with this slide, because it's the same thing. I think we have to prove to people how things can be better. And this project in Chicago was that they call Open Grid, where the intention is that every citizen can see exactly what's going on in my street, in my neighborhood. Things that are invisible to the eye, but data knows. Exactly what time will the garbage truck enter to my street? Exactly why is this lamp broken and when will it be repaired? How do the kids feel at school? What did they eat for lunch? And by the way, were there any crimes in my area last night and will they be solved? That sort of information that's always present, which means that people can be more involved in the city, but also that service providers get a much nicer possibility to do things efficiently, like this project in Finland where they've just decided to RFID tag the trash cans and thereby obviously can have much more optimized routes, and they say 40%. They have 40% less climate impact. Finally, the project in Copenhagen, which is not yet realized, but still in the plan, to build a recycling station where the station would, through sensors, experience if people have not been very good at recycling in Copenhagen. And by using data, they will know today's been a bad day. And thereby the idea is there should then be this like 30-meter in diameter big ring sort of produced by the factory that will be sort of spread across the city like a giant sort of you have not recycled, be better kind of communication. And yes, it sounds a bit stupid, but it's so interesting if aggregated data will give immediate feedback to people. What happens when we're not individually doing things that are collectively good? Because we can make things communicate and we can give that feedback, and maybe that will change things and it will change people's view on their part of this transformation. All right. I think with those words, my time is out. So I just want to say thank you for me.
Thank you very much, Sara, for a really interesting and somewhat touching speak. It makes you a little bit worried. But what do you do in order to not let the worries take over?
But I'm extremely positive and optimistic. Did it sound very worrying? I'm sorry. No, I think the opposite. I just think technology is absolutely needed to solve both democracy issues and environmental issues and health issues. Unless we sort of proceed, those things are never going to be solved. So I think, therefore, it's so important that we get more people on board, that we are more inclusive. Because if we get reactions, which I do think the political tension can sort of drive, that would be very bad for us, because we need to move in a pretty fast speed. So I'm super optimistic.
Great, good to hear.
Yes.
And what kind of ball would you like to put here? Where are you most?
I don't have to judge my speech. This is like my.
No, what are you doing as in your daily work?
No, I don't know if I do that, but I want to.
You want to. That's the most important. Yeah, great. Do we have any question from the audience? No? Okay, so
there's one.
Okay, there's one. Okay.
I'm Olof Schilén from Luleå University. We have a lot of choices as users of all these technologies, and sometimes you have the feeling that you join something because everyone else is doing it, without reflecting over environment and political issues, or whether it's fake or whatever.
Yeah.
So if you compare to other goods where we have a lot of information to make a good choice. So what do you think about this direction? Is there something more that could be done to make us make better choices?
Yes, actually, it's a great question. I do think that's a worrying part, especially when we look at information and knowledge and the way we now consume information without knowing why it's served to us. And I think that is an increasingly important issue to discuss. And I guess the only way to solve it is to have more knowledge and information about algorithms and why this is happening, and so people and users understand that what I'm reading right now is not sort of the worldwide agreed upon view on this issue, but instead something that is extremely targeted to me. And people don't know that, and it's very worrying from a democracy point of view. I think it's extremely worrying, and I do think the elections we've seen is a result of that. Because people get very divided and scattered pictures of the world. So yeah, the only way there are numbers of ways to solve it, but the best way is probably to educate everyone, so everyone is more aware. I hope. Yeah.
Mm-hmm. Okay, thank you, Sara. And we will give you a small gift. It's a backpacker.
Wow.
And a backpack. And it has been evaluated to be the best one. I don't know, but you will have to find out yourself.
Is it green? Is it ecological?
I hope so.
Thank you.
Okay, thank you.
Okay, so it's time to introduce the next speaker, and he comes from a company that is a verb. Today, it's Nicklas Lundblad, and of course, since it's Google, we all probably think about the responsibility of Google. They have a lot of data, we know that. Are they responsible enough? Maybe the Vice President of Public Policy and Government Relations can tell us that. In the EMEA, yes. He has 15 years of experience in this policy making with technology. So he knows, what he's talking about.
Yeah, right.
The interesting thing is the heading of his talk. It's what we can learn from Herbert Simon. I'm very interested in this. I have no idea who Herbert Simon is. I didn't have yesterday, but
okay.
now a little
You
bit.
will have. Yes.
Yes, thank you.
I'm on a. Thank you very much. I'm on a mission for Herbert Simon, and I want to make him more known. Let's see if this works. It's good. I just point out a couple of things before I start that are not about the talk I'm about to give, but it's good to challenge our metaphors from time to time. We've been speaking about data as oil for the longest time, and we're speaking about how much data has been generated, in the short while we saw our introductory talk here, which I think is one possible metaphor. It's also interesting to ask oneself how much oil was produced in that time. How many dinosaurs died and decomposed and turned into oil? The answer to that question is 0. No new oil was produced. But a lot of new data was produced, and the doubling rate of data is roughly 12 months now, which means that you get more and more data all the time. So I would suggest to you a slightly cheesy but kind of fun metaphor that you can go with instead, and yes, I am from Google. It would be data as sunshine, a renewable source of energy and economy and entrepreneurship. It's a lovely thought. I'm going to leave that with you, and then we're going to talk about Herbert Simon. Now, Herbert Simon is not coming when I click on this thingy-magic. There we go. Okay, Herbert Simon is a source of deep intellectual envy to anyone who is even remotely interested in research. He got the Nobel Prize in Economics in 1978, but the most impactful or the most amazing thing about him is that he was present at the birth of at least 3 completely pivotal sciences of the 20th century. So Herbert Simon was one of the first people to interest himself in the issue of how people actually really behave in economy. Until he sat down and started to research on this, we all assumed that people maximize rationally between all of their different choices and their utilities. Turns out they don't. And with that, Simon was one of the founders of what we now know as behavioral economics, a really important piece of economics that essentially shows us how people really behave in economic situations and upended much of the economic thought at the time. He then walked down the aisle in Stanford, where he was active, and spoke to a couple of other people about the nature and design of artifacts, and became one of the founding fathers of what we know as design science. In fact, my first exposure to Simon was here in this house 20 years ago, when Cecilia Katze, who was heading up the lab I worked at SICS, handed me Sciences of the Artificial, a small, very readable book by Herbert Simon. In which he sort of walks through how we can think about all of the human-designed artifacts around us. And then, I think, perhaps most importantly for me, he, together with Alan Newell and a lot of other people at Stanford, was a part of the founding of artificial intelligence. And that is what I'm going to talk to you about today. Learn about what? So what I want to talk about is this. I want to talk about the political design space for artificial intelligence. My day job is to talk to people all over what we call EMEA, Europe, Middle East, Asia, Russia, Turkey, about technology and its social impact. And one of the things I think is really important is to bring that back to the researchers at Google and all of the other research communities that I'm a part of, in order to have this ongoing, constant dialogue between society and research when it comes to the technologies we develop. The possible design space for any given technology is vast. You can do a lot of different things, but the actual political design space, what we decide to do together, is much smaller. And figuring out the relationship between those two is what I will ask Simon to help us do today. We will do it through looking at 3 essays that he has written, and we're going to just skim through them very quickly. This is sort of a Blinkist version of Herbert Simon, but I would really recommend you to read them at length, because they're certainly worth it and the time you invest in them. The first is an essay he wrote in the 80s called The Steam Engine and the Computer. This is an essay in which he studies the natural evolution of technological revolutions. And his first point, and perhaps the most important point, is that revolutions are slow. Technological revolutions are slow. The kind of urgency we're sometimes asked to feel is not necessarily the best way to deal with a quickly changing technical paradigm. The steam engine, he said, took 150 years until it thoroughly changed society. He even suggests a sort of constant for technological revolutions and says that any technology, any basic technological revolution, will take about 6 generations before it completely has changed a society. And he says there's no single technology at the heart of a technological revolution. In fact, what we see is always a web of different technologies growing slowly and enabling each other. With the steam engine, we saw the dynamo, and then we saw electricity. With the computer, we saw the internet, and then we saw connectivity. But it's not a single line, it's a web. And another part of the web that we're exploring now, and this goes back to the issue of AI, is this. With the computer, we've seen artificial intelligence, and we've seen the rise of something that is slowly approaching cognicity, which, in analog with electricity, is the ability to take cognition and use that as a fundamental general purpose technology in whatever you're trying to build. Simon's other point is that we shape technological evolutions. They don't happen to us. Far too often we have the sense that technological evolution is something that is sort of implemented by someone else, or it's a deterministic force that rolls over us. This is not the case. And this particularly holds for the political design space. It expands slowly and in webs. When we talk to politicians today about artificial intelligence, they're really interested in understanding how it connects with all of the other different areas, and that's why we as researchers and as policymakers and policy advisors have to be very careful and think about this. It's interesting in many different ways, but specifically when it comes to AI, this is true. I met with John McCarthy back in 2006. When AI celebrated its 50th anniversary. I looked him up outside of Stanford because I wanted to chat with him. And I asked him if he wasn't disappointed in the evolution of artificial intelligence at the time. And he looked at me and said, "No, you're stupid." To which I said, okay. And he said, look, it's really very simple. When Mendel had discovered inheritance, it took 50 years and nothing happened whatsoever. Then in the last 50 years, we sequenced the genome. We are only halfway through this technological revolution, and most of the stuff that will happen in the second half. Unfortunately, McCarthy died, or he could have called me up every single day and told me that he told me so, because he is right. If you look at the evolution of artificial intelligence post-2006 to now, you see a speed of development that is unmatched, I think, in the field itself. This is interesting for us as researchers because this second half is when regulation comes, when the political conversation needs to happen, when the social impact starts to become very tangible and real. Now, the second essay that we will use is one that is very sympathetic to read. It's called Altruism and Economics. Simon never believed in economic man. He never believed in this hyper-rational actor that maximized utility. He instead launched, and this was what gave him the Nobel Prize, the notion of satisficing, the idea that we try to find out what's good enough. And we're more than happy to actually be altruistic about it too. Altruism, he said, is a real observable fact if you do ethnographic studies, if you look how people behave. And if you want to do models of man, you need to take into account different kinds of biological boundaries. This is very true for the discussion we need to have about the political impact of technologies. All of the technologies we designed come with certain biological boundaries. In fact, sometimes those biological boundaries are the very reason we see a fundamental tension. Sociobiologist E.O. Wilson has a really brilliant saying where he says that our society stands in front of a grand challenge. And the reason we have this grand challenge is that we are moving at different paces. We have Paleolithic emotions, Stone Age emotions. We have medieval institutions in most of our societies, and on top of that, we have godlike technology. The tension between those different layers, Wilson says, is what we have to resolve. And that is what bounds the political design space for us. This is evident in a lot of different cases when it comes to AI, but perhaps the most interesting one to have emerged in the last in the last 18 months really, is the trade-off that we need to do between efficiency and auditability of artificial intelligence systems. We're now reaching levels of complexity such that we need to decide whether or not we want the system to be very efficient or auditable. If we want it to be highly exact and give us a lot of really good results, or if we want to be able to review these systems. Sam Arbesman wrote a brilliant book called Overcomplicated, in which he predicts that in a 10 to 15 year period, most of our systems will be incomprehensible to us, not because it's hard to explain them, but it will be an inherent quality of a system, not to be a black box, but, he suggests, a black organism. We need to move away from the metaphors of mechanistic explanation when it comes to computer software and instead shift into those of biological systems. The third essay, and the one where Herbert Simon most directly touches on the issue of AI and the reason for which we should be developing AI is called Designing Organizations for Information-Rich Environments. In this essay, he's asked by the Brookings Institute, this is in 1969, by the way, he's asked by the Brookings Institute to explain what they should do about information overload. Surely, the Brookings Institute says in 1969, there's too much information already. How can we deal with this? And he refuses to write that paper. Instead, he writes a paper called Designing Organizations for Information-Rich Environments. He doesn't talk about information overload. And the reason he does that, he says, is that, we can do a lot with this information if we just find out ways to deal with it, and that will allow us to accomplish a really important social goal. And I'll come back to what that goal is. The key quote of the paper is often quoted is this: with a wealth of information comes a poverty of attention and a need to allocate that attention efficiently. This is the tension in which the entire internet industry currently exists, between the wealth of information and the poverty of attention. The technologies we have, the technologies of Facebook, of Google, of Amazon, all of these different companies deal with this tension, wealth of information and poverty of attention. So what do we do to deal with this? In 1969, Simon says, well, it's obvious. We need artificial intelligence. Today, every single company, Amazon, us, Facebook, everyone else is investing in artificial intelligence to address this problem. But we quite recently, as you saw Sundar say, moved into the notion of AI first. For Simon, this was an obvious arc of development that we would all go through in 1969. And you can generalize Simon. You can say that we are sort of working with a tension here that's not only about information and attention. You can generalize them and say that we are in a situation where our social environment is becoming more and more complex. What we need to do is that we need to realize that we have a wealth of complexity and a poverty of cognition. And between those two, we need to start developing real technologies to help us learn. And that, Simon says, is the purpose of all of this. Artificial intelligence, the reason for artificial intelligence, the reason for us to have a social, political dialogue about this is this. Will you think me whimsical or impractical if I propose as one of those goals of artificial intelligence an order of magnitude increase in the speed with which a human being can learn a difficult school subject? So you can learn in a month what it would have taken you a year to learn otherwise. Social learning, the idea of social learning, is the golden promise of this technology and something that we need to shape, because the shape of social learning will shape our adaptation as social beings as well, together. And that's where we have a great discussion before us. Much of the discussion of artificial intelligence have been one of substitution, where we have said the machine will do this instead of you. That was simply a research paradigm that came to be because that was the way you got money from DARPA. You say, look, this computer can do this better than a human being. You would get money from DARPA. McCarthy, when I met him, was joking about this and said, well, we called it, look, Ma, what I can do period of artificial intelligence. The real value of artificial intelligence is in complementarity, when you use it together with a human being. Any computer can beat a human being in chess. A human being plus a computer can often beat a computer in chess, because complementarity gives us something completely different. Now, artificial intelligence will, through social learning, expand its own political design space. And I think that what we can learn from Herbert Simon, and what I would like to sort of send to the research world and to SICS, and to the work we do on artificial intelligence, because I do believe Europe is actually doing quite well. Startups in artificial intelligence in Berlin, in Paris, in the UK are as many as those in the US. Many of them are bought by American companies, yes, but that's because there's no single domestic market for them to develop in Europe. So what can we learn from Simon? We can learn, and I think this is essential when it comes to research. The AI is probably the most political technology we've explored so far, and the design of it is increasingly a political act, which means that we need to talk cross borders, not just research, but research and policymakers and businesses in order to design these technologies, which is why I think a research institute does really, really well. Thank you.
Of course, we have a lot of questions in the audience. Any questions around?
No.
They don't dare to ask the questions. Yes, safe.
So, given the message that you just said, how is this related to Google, where you work at?
Well, I mean, if you look at the amount of money we invest in research and how we have developed an entire organization, part of which I lead, for social dialogue, I think that is very much a direct response to the kind of analysis you see here. That these technologies are not technologies that can be developed in isolation. They need to be developed in a social context, in dialogue with the world around us.
Does it shape Google then?
Yes, yes, certainly. I mean, look, there are several different things that we where we have looked at, for example, facial recognition, and said that the social acceptance of facial recognition is fairly low. There is no need for it, so we've decided that that's something that we want to. Or take the launch and then collapse of Google Glass, which is an interesting case as well, right? Because Google Glass could have been immediately mass marketed if we wanted to. We had the resources to do that. The logistics would not have been difficult. But the people behind Google Glass said this is a technology that needs to be negotiated. So they consciously put it out in very small volumes, and we could see it fail because of the social weave and context in which it was asked to exist. That is a way of thinking of technological development that is deeply ingrained in what the company does. It comes from the original idea of release and iterate, which is sort of a basic tenet of Google faith. You release something, you iterate when you see it in use. The open innovation paradigm at work. And that is something that then comes back on a semantic and political and social level as well.
Okay, there we could hear his background in public policy.
Yes.
Maybe we...
I get to throw a ball
another
now?
question? Yes.
No.
Bruce Line, KTH. I wonder if you comment on the vulnerability of the architecture that's being set in place here. If we're going to be very dependent on AI and data analytics and so forth, information from Google, if you will, speak to two components. One has been in the news recently, and that is, of course, the ability to hack systems and bring them down. And then the other is the attention deficit that you talked about, and that we accept material now that is perhaps not deeply analyzed or vetted, and you get a lot of misinformation coming at you, and sometimes for political purposes. I'm talking about the US election and so forth. So comment on the vulnerability of what the architecture we're talking about.
I'd love to do that. And there are two comments. A vulnerability is a vulnerability in relation to an existing system, which means that every system has a vulnerability. So if you think about an offline system or the system we have today, it has an increasing vulnerability, not perhaps in its information architecture, but in the complexity that surrounds the system increasing so fast as to make the system obsolete. So you have to look at functional equivalence. When you look from one technical solution to another, the idea is that vulnerabilities should be managed in a better way, but they will always exist. So risk management across technological system shifts is really important. I think that in some senses, we are probably in a situation now where we see increased risk because we're at the beginning of a shift, and that needs to be corrected for. And I think that there's a lot of work going on to do exactly that. When you look at artificial intelligence and security and hacking, etc., you don't want somebody to hack your self-driving car so it becomes truly self-driving. That's a bad thing when it happens. So what you instead want is probably certain security mechanisms. That research is essential, and it's happening now. On the other question, I think, on the attention deficit, it is really difficult because the amount of information is growing so fast. And what is happening here is that we have to shift the view of information systems. Simon, in his 1969 article, says the main purpose of an information system is to restrict access of information, not provide it. And those restrictions, and this is really interesting, right? That's his basic thinking in 69 is that the main purpose of an information system is to restrict information. When you do that, you open yourself to ethical, political, and I think, general scientific questions that have to be resolved. It's about the transparency of the filtering mechanism and the auditability. That's why the auditability question and problem is so deeply interesting. And there's a whole workshop and a new track within the ACM on this stuff that I can strongly recommend, because I think that's going to be a key issue for us as we move forward into this age.
Okay, thank you. Now we need a ball from you.
Sure, and I also...
A couple of them. Wait, you can choose between green, which is blue today, red, which is the heart, and yellow, it's the pocket.
Okay, so I will do this. There's an
Economical.
enormous amount of data produced. There's no scarcity. I'll take one of each.
Great, good. Thank you. And you'll have a backpack as well.
And we have a gift for you as well.
Thank you very much.
I would also like to welcome our audience that is also in the next room to us. Right now we're having a break, and we will be back 11:15, right? And then I think there is enough room, so you who are in the other room, you are welcome to this room after the pause. So see you again 11:45.
Anders Henriksson har bjudit in mig. Han rapporterar till mig. Okej. Men kommer... Jag kommer prata några datum med dig. Nej. Vi tar någon gång när jag har... Hello. Please squeeze. Please squeeze. We need... We are trying to move the people from the second room into this room. So please squeeze. There is some good old friends.
Bara ha den dörren öppen, så blir det inte så slammig.
Ja.
Jag presenterar Daniel då,
Ja.
sen så kör vi.
Det är du. It's you.
Vad har vi för tid?
Jag ska
Jädrar vad
koppla in
duktiga.
sin dator först.
Nej, men jag tror att du kör inte från den. Okay. Really good. You really made it. It's 11:15 and you're all here. It's amazing. Really good. So the next speaker is our own SICS co-worker, Daniel Gillblad. And Daniel, I think quite many of you know as director of the DNA lab, and DNA in this content mean decision networking and analytics. And those of you that don't know Daniel from there, maybe you know him from TV, because he's also a TV star, aren't you?
Well,
So if you participate in quite a lot of programs, but maybe there will be a reality series or something where...
yeah, Big Brother is
Yeah,
next, I'm
something.
sure.
No,
Yeah.
no, big researcher or something. Okay, so now you will talk about artificial intelligence beyond machine learning and what we at RISE 6 are doing in this area.
Yes,
So,
absolutely.
welcome. Yeah.
Right, so thank you. Yes, I'm going to talk a little bit about AI, and I'm going to talk a little bit about a future perspective. What do we need to solve in the next few years? What do we need to work on? And what specifically are our interests here at RISE 6? What do we want to work on, and what do we want to build? And I'm going to start at the very, very basic, just to make sure everybody is on the same page, basically. So what is machine learning? So machine learning is the ability to learn and predict from data without explicit programs. So instead of just manually crafting programs, or for example, expert systems or something like that, representing human knowledge, you build a model that you can train by looking at just lots and lots of examples, and you train it to do something. So this has become a key cornerstone of AI. This is a part that really starts working now, and we really, really need this to build real AI systems. So machine learning has almost become synonymous with AI in the last few years. However, this is not at all true, and we'll get to this in a short while, basically. So why do we have all this hype about machine learning at the moment? Well, we've had a few really, really successful examples, mostly within the area called deep neural networks, which is take a neural network, which is a simple model approximation of the human brain. Just take an input, weigh it by linear weights, put it through a nonlinear transformation, and put it to an output layer. So if you stack lots and lots of those, and you're able to train them, you can actually represent abstract concepts in, for example, images. So at the first few levels, you represent more lines and things like that, later on patterns, and perhaps at the top, human faces and things like that. And this is an incredibly powerful tool. So this is the performance on a standard object detection database. So in 2010, you see that the performance of the state-of-the-art was so-and-so. The performance in 2015 and 2016 is really, really good. So this is the error on this database. It's the error. And the red line represents human performance. So for 2 years now, machines are better at this than people. You can also train these things to do a lot of other stuff. These are actually just training examples. But for example, if you have both text and images, you can train these things to look at an image and generate a description.
I'm presenting this picture because I'm going to actually use it later on to say that this doesn't actually really work that well. But we really have to look at why do these things actually really work well now? Well, first of all, of course, there's increased interest, more investment and things like that. Of course, we're better at methods and algorithms. But if we're looking at, for example, deep neural networks and other techniques, what really changed is that we have a lot more data and we have a lot more compute power, and we know how to harness it. This was the key point that made these things work. By using these things, we can build huge representations of the world and actually train them. And right now, actually, within the area of machine learning, one really, really big issue is to understand why these things actually work very well. Because if you just look at it mathematically, they should not be as good as generalizing as they actually are. So this is really, really interesting. But if we really, really want to build AI from these systems, you need a lot more things from these models, basically. And this is what we're looking at SICS at the moment. First of all, we need to make decisions based on the output of these models. To actually do that, we need results in time and based on fresh information. We need to train and predict basically in real time, in really, really short time. Nowadays, all these models are really batch-oriented. You take a lot of data, you train it for a long time, and you deploy it, and that might take some time. We really need to fix that. We really need to build causal models. We need to understand what causes what, and not just how things are correlated. Perhaps even more importantly, as a first step, we need these models to be able to tell us how unsure they are about a prediction. So if you, for example, predict that there is something in an image when you have an autonomous car or something like that, it really, really makes a difference if you predict that it's a, I don't know, garbage bin or something like that, and you're really certain, or if you predict that it's a garbage bin and you're really uncertain. The decisions are going to be completely different, basically, because in the latter case, it might be a kid or something like that. And if we really want to base real decisions as a human or an AI on these models, they need to be able to explain themselves. Why do they make this prediction? This is very lacking today. And the other thing that we're trying to solve at SICS, that we have unique competence in solving, is the fact that ML really, really lacks in efficiency in several dimensions, basically. First, in terms of data, we really need a lot of data to build these really good, complex models. We need to fix that. But they're really also inefficient in terms of computation. We really waste a lot of power here. And here we're going to build systems that fix that. And they're really inefficient in development time. You would be surprised how long it takes to build these really, really advanced machine learning systems that you see as examples, fantastic examples of successes, basically. So we really need to fix that. So let's get back to artificial intelligence. And artificial intelligence is way more than just machine learning. It's not just learning how the world works from data, it's actually making active decisions. And machine learning has been artificial intelligence has been around for a really long time. It was defined in 1955 as a proposal to a summer school by some people that you might recognize, John McCarthy, for example, Marvin Minsky, and some Claude Shannon that did some contribution to science. But he was actually part of naming this. So it's been around for a really, really long time. We have a massive amount of results, basically. And if you look at some things that have been presented as real amazing progress in AI for the last few years, we can take, for example, the AlphaGo example that Google presented last year. So last year, Google built a machine that actually can beat world champions in Go, a very, very complex game. In this, they do use these deep neural networks to try to basically guide the thing through the search space. So what you do is that you look at the position on the board, you try to play out all possible games, basically, but these are a lot of games. They train these neural networks to guide the search so that we don't have to search everything. But another key component that is probably even more important is that they built a really fast Monte Carlo tree search algorithm. And this is from a completely different part of AI, basically. But this is what this makes, what this AlphaGo work, basically. So there's a lot of other stuff from AI that we're now bringing in to actually build these systems. Now, let's go back to what we actually really need to build to make more smarter systems. So let's just think about a very, very popular sciencey concept, basically, that Daniel Kahneman defined in a book called Thinking Fast and Slow a few years ago. There he talks about two systems, and these are actually not too bad metaphors about what happens in the systems that we want to build as well. So system one is basically really fast and intuitive. It's just reaction, basically. System two is much slower, but reasoning, thinking about the results and things like that. Right now, in machine learning, we're building system one. We need to build system two. This is incredibly important. To build the next step, we need to build system two. Because if you want to predict, for example, what's in these images based on just training data, and you this is presented to a deep neural network that was trained on standard data. If you look at the middle picture, an airplane is parked at the tarmac at an airport. I mean, this is not, you can see why it describes it like that. There is tarmac or something similar, there is an airplane and so on. This is the logical conclusion if you just react, basically. But there's absolutely no reasoning behind it. So this is what we at SICS really want to do as next step. I'm not going to go into detail in this picture, because this is just a really brief overview of the AI systems that we want to build. But basically, what we are good at the moment is the perception part. We can actually perceive the world and make quick decisions. In the next box there, the reasoning part, we're really not very good. And at SICS, we're actually looking at bringing in other parts of AI to machine learning to build these kinds of systems. So this is a graph representing, I think it's actually Wikipedia, but Olof Jörnerup, who created this picture, might actually have another opinion. I'm not actually sure. Okay, good. It's all words existing in Wikipedia. And you look at every word and how it correlates, how it co-occurs with other words, basically. And just from that simple statistic, and if you look at these distributions, you can find out how exchangeable words are, how similar are they in use. And you can cluster them, find abstract concepts such as colors or vehicles and things like that, and actually we can start reasoning about them. And we can start reasoning about these things perhaps in terms of analogy and things like that. So if you want to, just from a massive amount of text, find out who Barack Obama's wife is, you put out a question. So Barack Obama relates to X as husband to wife. What comes out, basically? And we're starting to be able to build these systems. Another core concept that we need to fix, though, is the fact that if you just look at text, this is an eatable tropical fruit. Nobody states the obvious in text. Nobody says that it's yellow. This is too obvious to actually write about, basically. So what do we need to do? And this is actually a core concept to actually build real AI. Well, we need to look at multimodal data. So if you look at text together with images and things like that, you can actually see these concepts as well. You can see these obvious statements. This is an experiment done on, now you can't see that, that's actually, we have been using a deep neural network to build abstract concepts of what's in images, basically, and do a classification, and then using standard techniques for natural language processing to build these graphs that we can actually reason about, and it can detect concepts here. And we can do this in the future, hopefully, on a really fast and large-scale manner on all kinds of multimodal data. So one of the key things that we actually need to do to bring these systems to life is we need to build a home for them. We need to build a real home for machine learning and AI. There is no such thing yet. We spend enormous engineering effort to build these really, really large-scale systems. We need to fix that. But we have a plan. And Farid here is the PI for the project that is going to be the core of AI research and machine learning research at SICS. And here we're actually going to build all platforms, all the way down to implementations, systems, and so on. So if you look at this, the last 5 years or so, we've been working on cloud computing, stream analytics, and so on. Now we're moving to continuous, deep, declarative analytics. So what do we mean by that? Well, by continuous, we mean non-interruptive, non-intrusive processing, and models that learn and train continuously, basically, continuously updated. By deep, we mean complex properties in the data can be modeled. They're interpretable, layered, like, for example, deep neural networks, and so on. And computation-wise, arbitrarily iterative, and we can combine both historical and live data. And finally, to fix this problem of productivity, they're declarative. Convenient programming models for any type of data. If we're working with a graph representation, if we're working with tensor representations, or anything, we're going to provide a system that is completely transparent. And this is basically what we envision now at the moment. At the top, we're going to do a lot of work on theoretical ML, addressing the questions that I've just described for you. And under that, from the bottom, we're going to build a distributed runtime that performs optimizations in runtime and can provide live progress monitoring, an intermediate language on top, and at the top, declarative programming. That means that we can have a complete system to build AI solutions on. And now, just to conclude, because my 15 minutes are over, just want to summarize a little bit what I've just said. First of all, AI is a lot more than just machine learning, and I'm saying that as a machine learning researcher. I would also like to say that there is a lot more to discover and rediscover within AI that we can actually put to use, as long as we have large-scale systems to work on them. Reasoning systems are key to learn from small data and to actually build really sophisticated solutions. We really need to broaden our scope of data to build wider AI, and systems and platforms matter enormously. We're not going to be able to build these things unless we take a whole view of the whole complete system stack, basically. But that's what we're going to build in the next 5 years. All right, that's it for me. Thank you very much.
Thank you, Daniel. Do we have a question from the audience? It should be a lot of questions. I think there are really... No? Over there.
Daniel, I'm curious to ask you, how would you think to build System 2 thinking machines only by processing text and images? So what is the role of symbol grounding, of situated learning? So the role of the body to come to this System 2 thinking, which may include cognitive functions like reasoning, attention, and things like that.
Yeah.
Thank you.
Yeah, very, very good question. And no, I don't think, as a very general answer, I think that if we want to build something that really represents an intelligence that sort of reflects the intelligence we have as humans, we need to also build something that manifests itself sort of as a human. So it's not just text and images and so on. It has to be some kind of agent that sort of lives in a similar world that we do, basically. So there's going to be a lot more work to do, a lot more types of data and things like that to build that kind of general intelligence.
Mm-hmm. Thank you. Yeah, it's really interesting because there are always these questions about what kind of reasoning are you seeing forward?
In these models?
Yeah.
Well, hopefully more and more general questions that you can actually do basically unsupervised learning and ask it more or less any question. Ask it to predict whatever or ask it about the probability of any kind of relation between symbolic concepts in the data, basically. Hopefully.
Yeah.
But this is going to take time.
Yeah. Good. We have another question. Yeah.
Okay. It would be interesting to know what kind of application areas you're using when you're starting this.
Yeah.
Must be some. Is it text, quantitative, or a combination, or images? Or which kind of customers do you have in the beginning working together with you?
Right. So we have our close partners. For example, Ericsson within telecom, Spotify within, Volvo have lots of applications both in, for example, vision and in all other areas. So within transportation. But then again, to try to develop these things, we also need very, very large data sets and so on, and we use what is available, basically. So good starting points are text. There's a lot of text. There's quite a lot of images as well, and so on. So all these things are very, very good and straightforward starting points. So it's a bit of both sensor data from all of these systems that we're talking about, but also more public data to bootstrap ourselves.
Great, thank you. Sorry, now we don't have any time left. But Daniel,
yes.
What are your impact on sustainability? What are you doing on daily basis most? Is it economical, environmental, or social, or?
This is everywhere. This is can I put a ball in everything?
Yeah, of course.
Yeah. Okay.
Good. Thank you very much.
Thank you. And now it's time to introduce the next speaker. And it's Theofilos Kakantousis. I hope I got it quite okay. And he will present what is behind some great news we got yesterday evening. The team won IEEE Prize Scale 2017 on the most scalable system. So it's a super great prize. And they have the world record in Hadoop operations, this team. And his title is Multi-tenant Streaming, I guess, Analytics as a Service with hops.
Thank you. So, hi everyone. Thank you for having me here today. I'm going to present multi-tenant streaming as a service with hops. It's a short talk, so I'm going to provide a brief overview, but we have a couple of posters upstairs later on. So I will be happy to discuss with you all the low-level technical details about hops. So streaming as a service, we provide it with hops, which consists of the backend system, hopsfs, the storage layer, and hopsworks, the front end, which supports Spark, Flink, and Kafka as a service at the moment. It runs on RISE 6 ICE data center up in Luleå. We have a collaboration with RISE 6 ICE. It is a research and test environment. It currently consists of around 1,000 servers, but the plan is to increase it to 5,000 of them in the near future. So Hadoop is not a cool kid anymore, it seems. So that was a motivation also for hops to evolve as a product. There are so many platforms and services around the ecosystem. And so what went wrong with it at first, and what we solved? Hadoop started in 2009 as a distributed framework for doing analytics on large datasets, on big data. Then it started evolving and growing with more features and services, but the services that actually handle the storage did not evolve equally. So it started, especially the name node in particular, it started becoming like the bottleneck of the entire system. After some hard work, we managed to solve that, and not only that, but as it was mentioned before, we now have the most scalable and fastest Hadoop platform in the world. It is at least 16 times faster than original Apache Hadoop. It can scale more with even more hardware, and this was measured on Spotify's workload. And it can store at least 37 times the number of files compared to Apache Hadoop. So now that we have such a scalable platform for the backend, we decided to make Hadoop easier for people to use. So we decided to make it simpler. We have introduced the concept of projects with hops. So instead of clusters with Hadoop, you get a project in hops. And the users have access to either datasets, the files in the systems, in the system, or topics, which is a temporary storage layer, let's say, for live data coming in from different systems. The users can apply their business logic by running some jobs or Python notebooks, for example, and they do all this securely by using SSL/TLS certificates. Also, there is no need for a sysadmin because all that is provided from a single self-service UI platform within your browser. So to go a bit more into detail about what a project is in hops, imagine you have 3 users and you have also datasets and topics. So you can draw a line around the users you want to include in your project. So for example, project 42 has these 2 users, and we can draw another line, project X. Now we see that user Alice, the one in the middle, is member of both projects. So Alice logs into the system by using her email, as you do with most platforms nowadays. But then Alice has a view of the project that she is member of, or she can create another project. Then she goes into the project and she can run her jobs by using the unique identity she has in that project. That allows us to have isolation of data between projects, so Alice cannot do cross-linking between data. Data is isolated and securely stored in this project abstraction. And of course, you can have more users in another project where all your users are part of a single project, for example. So the data channels are either Kafka topics, as I said before, like collecting data from live streams, or HDFS datasets, files actually in the file system. Now that we have established what a project is in hops, we decided to build a streaming platform on top of that to allow users to easily run the streaming applications. So to do that, first you need a data ingestion point. For that, we decided to use Apache Kafka, which is a highly scalable distributed framework. So data is coming from different sources. It can be either a Twitter feed, or it can be data from sensors that, for example, report humidity or temperature. So the sensors report live data. They come into this single ingestion platform. And then data scientists and users can run their applications. They can apply their business logic by using either Apache Spark or Apache Flink. They are both well-known processing frameworks that are integrated into the hops platform. So the user, as the events come in, applies the business logic, and then usually you get some useful information out of it. You want to store that information somewhere, so you have your sinks in the system, which in hops, they are represented by shareable datasets. That is, you go into a project, you have a folder where you store your data that your application has been all this time processing. And you can also share this dataset with another project. So other data scientists, for example, can run their code on your data so they can do their own analytics. All this securely without them being able to copy data, of course, out of your project. Also, as the application is running in real time, you want to have some debugging. If something goes wrong, if one of your executors crashes, or you want to see how much traffic is generated with the file system. All that is done securely by using SSL/TLS certificates, which means that the platform automatically generates a certificate per project and per user. So user Alice is member of project A, so the platform generates a certificate for Alice in this project. When Alice is running a job, then this job uses this certificate to access either Kafka or the file system. All that is provided by a single point of entry, HopsWorks, which is a self-service UI, and this is quite important because traditionally Hadoop has been evolved around having someone going into the terminal and doing an LS to find the files, or submitting the job from the command line, which is not that easy for people that are not experienced with this. So we have HopsWorks, this UI that the user can navigate to all of his services from the browser. So that's what it looks like. So you can create, for example, a Kafka topic, and you can also share it with another project, and you can do more fine-grained stuff, such as having access lists for the Kafka topic for the members of the project. Here, you can do free text search by using the ELK stack, Elasticsearch, Logstash, and Kibana. You can do free text search on your application logs in real time as the application is running. And you can do monitoring and alerting on your application. So you can view how much data is being written or read from the file system, or how much network traffic is being generated, or how much memory each of your processes is consuming. Also, when you have data in your SICS, after an event has been processed, usually you want to do some analytics on that. So we have Apache Zeppelin integrated with hops. And for example, a data scientist can open a Zeppelin notebook, and then he can run a standard SQL on that by using Spark or Flink. So you can do some analytics and generate some BI reports, for example, based on your real live streaming data. To make it easier for programmers to write their applications, to apply their business logic, we have hopsutil, which is a library that greatly simplifies the actual program that is running with Spark or Flink. So the platform already knows all the endpoints and where the services are, so the programmer doesn't need to input that in the program. You just call hopsutil, you want your Spark or Flink process, and then you are good to go. So that was a brief overview of streaming as a service with hops, but currently we're also working on integrating deep learning into the platform. We have integrated TensorFlow, and it's currently available for early access users on hops ICE on the data center I described before, and it will be available for all the users of hops ICE in a couple of weeks. So to sum up, hops is the only European distribution of Hadoop, and it's the fastest in the world. We won the award as well. And it provides first-class support for Spark, Flink, and Kafka as a service. Of course, it's not only streaming. A lot of people want to do to run their batch jobs as well, so you can do that from the same interface. This is our team, past and present. And we also have a company called Logical Clocks in order to commercialize on this new exciting technology. Thank you.
Thank you, Theo. First, questions from the audience, if there are any specific questions. Welcome. Don't the Ericsson guys have some questions? No? What about the Spotify guys? Olof? I can repeat the question.
I wonder, when you do the streaming analytics, do you do it in small batches or how do you set it up?
When you do the streaming analytics, do you do it in small batches or how do you set it up really?
That depends on the framework, on the processing framework that you use. If you use Spark, then you have to define the batch interval of your stream. So you can set it from 1 second to 10 or whatever minutes you want. But if you use Apache Flink, yes, if you use Apache Flink, it has better support for streaming. So it can process events. You can apply your business logic per event. You don't have to do micro batching as in Spark. So you have both options.
Yeah. You said a few words about TensorFlow in the end. What kind of tools are you going to use to give that service to the users?
So at the moment, we're integrating TensorFlow natively on Yarn. And the important thing is that we provide scheduling on GPUs, yeah, on the graphics card that there are on the cluster, isolated scheduling on the GPUs. We also have support for TensorFlow on Spark. So if someone wants to do deep learning by using the Spark programming model, they can do that as well. And we also have a test bed with InfiniBand installed, InfiniBand. So the plan is to have some tens of GPUs in the future. Yes. So we have a full solution, a full cluster where you can run your deep learning with TensorFlow.
Okay, so there is where my investment in a lot of GPUs will go. Very good.
It's expanding.
That's important that your data center now has GPUs and InfiniBand, which makes it possible. One of the very important platform for doing machine learning.
Yes. Yeah, so safe just to mention that that's why it's very important that we have GPUs and hardware implemented so we can do our platforms all the way from hardware up to the top level using when we're going to do this AI project. So we have our own hardware to run.
Yeah, it is there already and it's expanding. We're adding more and more as time goes on.
Yes, and where are you in this world of environmental?
There are no balls left.
Social, or is your heart? You work for the pocket domain, or is it a green IT, or where are you?
Okay, this is the heart.
That's the heart.
Okay, I will go the heart.
The social interaction. That's
Yes,
your
you got it.
feeling. Yes. Very good. Thank you.
Thank you.
Okay, so now we will involve you as an audience in this project that we're having here. So we want all of you who think that you are working or engaged in economical sustainability to raise now.
Stand up. Stand up, please.
Stand up.
It's a little break, so please stand
yeah,
up.
Yeah, it's a
So those are
break.
in the economical, stand up.
Yeah. Okay, good.
Okay.
And we are thinking like the votes from the audience are always, you know, they are highly weighted.
Yes.
So we have 3 balls, but I think 1/3 maybe is
Yes.
standing. So,
Yes.
okay, please sit down.
down.
And then we have the next one is on environmental sustainability. So those of you who think that you're engaged in environmental sustainability, please stand up. Good. So that's a 1/3 or? Yeah? 1 ball? Yeah. Okay, so and the last one, the sustainability. The heart.
The social.
The social
sustainability.
sustainability, sorry.
Good.
Good. Yeah, so now we have 2. Yeah, great. I hope every one of you have been standing now.
Yeah,
If
there was
not-
supposed to be some kind of a break.
Yeah. Thank you. Okay, so now we'll go on to our next speaker. It's Shahid Raza, and you are quite new as a director of the security lab at SICS, some months ago.
Yeah.
And then now you will talk about cybersecurity in the era of IoT and cloud.
Yeah.
Welcome.
Thank you. So here comes the showstopper, security. My name is Shahid, and I have been working at SICS since 2008. Recently, I have given the responsibility of security lab at SICS. Today, I'll talk about the cybersecurity in the era of IoT and cloud. Because of time limitations, I'll focus on one specific research item we have done, but I'll give you a quick overview of the lab. It's great to see that we are the best in everything. So cybersecurity, it's the biggest cybersecurity group in Sweden, the RISE 6 Security Lab. We are 19 members, 2 affiliates, and we are in 2 locations, Stockholm and Lund. And when it comes to research, we work on different topics, basic research or disciplinary research, system research, and also very much application-oriented research. These are some of the keywords where we work with. Am I clicking here? Here. Core of our research, I would say, or the main topic where we work on is IoT security, cloud security, I would say cryptography, a lot of it, and many more. So if I categorize my lab's core expertise, it falls in these 6 categories. IoT, 5G, software, cloud, and privacy and blockchain. I'll come back to this in the last slide, but today I'll talk about one of these. So our research is funded by many Swedish and European projects. And today I'll talk about one item, which is Internet of Things. That's my personal research area, and that's what I know the most. So before I go to the security, Internet of Things is a network of globally identifiable physical objects. And there are some unique characteristics of, that Internet of Things have that makes it different from the rest of the networks. And these are most IoT devices, when we talk about 50 billion devices or 26 billion devices, they are resource-constrained devices. And they are deployed in networks where the networks are lossy, that we don't or we can't expect a continuous connection between these devices all the time. Sometimes these devices they have a short range, so they route data on behalf of other devices. And they are deployed in unattended environments, which means there is not always a user behind an IoT device, and there are no interfaces either. And they are extremely heterogeneous. When we say IoT device today, though we focus mostly on resource-constrained devices, it covers a wide range of devices. An IoT device can be a sensor which runs on batteries for 10 years, 20 years. It can be a refrigerator, it can be a TV, it can be a car, it can be anything which is not a general purpose computer is an IoT device. So one of the technologies, enabling technology behind IoT is IPv6. But IPv6 is there for more than 2 decades. Why there is so much hype today about IoT? And I think it was around 2007 and 8 when IETF, Internet Engineering Task Force, the organization who has standardized the Internet protocol, they came together and they said, let's have IP in extremely resource-constrained devices. And they developed a protocol called 6LoWPAN. 6LoWPAN is nothing, but it's a compressed version of IP when it comes to resource-constrained devices. And from then onwards, we have so many applications, we have so many players who jumped into the IoT space. But still, the basic protocols are still coming from IETF, Internet Engineering Task Force, the organization who has built the Internet protocols. So this is a picture of an IoT network, I would say. You can draw many pictures. We have, here. So we have a network of resource-constrained devices. In IoT world, it's called 6LoWPAN network. We connect it with the internet through IPv6 communication. And when we are in this part of the network, we use a compressed form of IPv6. So for so good, we can use this architecture to build enormous applications. Now, potentially, we can connect any physical object by embedding a small microprocessor in it with the internet. However, the actual reality is a bit different when it comes to security, and that's my talk. State of the IoT security today is like it was in IT security in 1980s. There was hype on internet, and vendors just rushed into the market to bring their products into the market without caring about security. And this is the state for IoT today as well. And this is one of the main reasons every next day we hear in news, IoT is broken, my thermostat is broken, and it was, I think, 21st of October last year when the biggest IoT security hack was disclosed in the form of a Mirai attack that has downed the internet for hours. And when it was the biggest IoT hack, and it's one eye-opener. When big sites like Amazon, Spotify, you name it, they were down for hours by an attack, by a network of IoT devices. This was called Mirai attack, by the way. But as I said, the main reason IoT is broken today is people are just rushing into the market without caring about security. But I would say now we are in the stage when we really seriously thinking about security, especially a push from the Swedish government, I would say, EU, and other society in general. So SICS, since 2010, we have been working on IoT security, and we have developed so many protocols. I will highlight very quickly something here which you can use today in your product and services, and then I will give you some future directions as well. So I think most of us are familiar with this stack. This is a typical stack in an internet host. Some of you might have seen this. All these jargon here, they are IETF standards. They are the protocols which are already standardized by IETF to use in IoT devices. And we can connect these two worlds using a compressed form or a lightweight form of all these protocols to keep end-to-end security. I'll continue this with this picture. If you are an IoT service or product provider and you think about security, usually we have two ways to provide security, something which is called end-to-end and something which is called hop by hop. By end-to-end security, by hop security, we mean if you send something from source to destination, all parties in the middle, intermediate parties, they can see the contents of the message. On the other hand, when we have end-to-end security, there is an end-to-end trust between the sender and the receiver, and no one in the middle is trusted. And today we have protocols which are tailored or primarily designed for IoT devices, and you can run them in battery-powered devices and keep a battery life more than 5 years. And I highlight those protocols. One of them is called OS-CoAP. It's called Object Security Protocol. It's an adapted IETF standard, and SICS have worked on this standard together with Ericsson for over 3 years now, and it's close to be a standard. And the other one is the CoAP S, or Secure CoAP. It is very similar to when you use internet, you say HTTP plus TLS, it becomes HTTPS. We can use today something like CoAP plus datagram TLS, and then you can make CoAP S. And as I said, it's a standard now. This URI is available now, and there are a lot of implementations. There's another possibility which is ready, implemented, tested, and evaluated is the IPsec, the Internet Security Protocol. We are familiar with IPsec when it comes to VPNs, connecting different organizations together. But IPsec has a little used, I would say, mechanism called transport mode, where you can have end-to-end security, where you have end-to-end security between two machines using IPsec. And there are open source implementations available that you can use. And the last but not least is the link layer security. We are all using Wi-Fi, and the Wi-Fi security is link layer security or per hop security. It's just between your device and the router. And after that, there is no security if you only rely on Wi-Fi or link layer security. So to summarize this whole thing, if your requirement is to use end-to-end security between two data items, you go for OS-CoAP. And this is the lightest protocol, I would say. If your requirement is to go between two applications, go for transport layer security or DTLS. This is a standard now. If your requirement is to protect two machines and also the IP headers and IP packets to save against or guard against the IP spoofing attacks, which is one of the main attacks that leads to the DOS attacks, then go for IPsec. And if you want to just secure the two links, if you don't have a multi-hop network and you have other security mechanisms, you can go for link layer security. I'm not educating here which security mechanism is good or bad. It's up to you. The message here is we have protocols standardized, available, and implemented. And this is what we have been doing for the last 7 years. It's not so easy to run IPsec in an IoT device and get a better performance, and this node will be running on batteries for 5 to 10 years. So it was very challenging. Yeah, so these three first protocols, they give you end-to-end security between machines, applications, and data items, and between two links or between two hops. So this was what is available today and what we have been working on, and what you can really get it and use it. I'll show you one more slide where you can find what. But these are the three things which we think nowadays is really something which is missing. And in all these protocols and previous work, we have been using something called pre-shared keys or symmetric cryptography only. This can scale well if you have a limited network with few nodes, but definitely not for billions of IoT devices, which are heterogeneous and deployed in harsh environments. And I'll talk a bit about identity as well today. But then we could have malicious vendors in IoT space, which means every vendor today, I would say, they leave backdoors, if you agree or not. And there is no easy way to detect them except you use open hardware and open source software. That's the only two ways, that we can defend against these big guys. Another thing is privacy. We never worked on privacy before. We did work last, I would say, 1 year or so. But the main reason was that the privacy is a prohibited world in industry because it limits innovations. But because of these new regulations, it's a law now to preserve privacy. I'll come back to this in a couple of slides as well. So very quickly, I think I am losing the time. The backbone of any security solution is the key. That key you use to protect your communication, your data, whatever. And in IoT world, there are 3 ways to manage or use keys. One is pre-shared keys, one is raw public key, and third one is certificates. The inherent limitation of pre-shared key is that both end knows the same keys. And you cannot make this system scalable up to billions of the devices unless you use some sort of trusted third party. And if you have a trusted third party, for example, in this case, it's called Trust Anchor, you share a single key with this anchor, and then this, every time if someone wants to talk to you, it comes through this anchor. This solution is now an Ericsson pattern. We work on this solution during this, and it's so amazing that you don't need to change any existing standard and you achieve scalability if you can afford to have a trusted third party always available. But as I said, the state of the art in the internet today is asymmetric cryptography, or something called PKI, public key infrastructure. And we rely on this heavily for all transactions we do on the internet. And one of the questions we asked ourselves 2 years ago, can we bring this into IoT world? And what are the limitations, and how to use asymmetric cryptography with certificates and everything, the state of the art on the internet into IoT devices, which is also an internet of things. And luckily, or I would say consciously or deliberately, all standards, they specify that we can use asymmetric cryptography. So we are not the only ones who say that we should use asymmetric cryptography, but we are the ones who give the solution how to use this. These standards only specify that asymmetric cryptography could be used. So our solution will be standard compliant. We started a project called CBOT. It's called Certificate Enrollment in Billions of Things, and the main aim was to give identities to the IoT devices. Though it was a small project, we solved one basic problem, which is called enrollment. And enrollment is the process of certifying keys. If I have a key, how do I certify that belongs to me and I can use it? This is together with Nexus. I guess you know Nexus. This is the company which is behind this technology. They provide this behind this bank ID we use every day to log in to our banks and our websites, Kateworkat and everything. So this is the main technology. Enabling technologies are from them. They are our really industrial partners. So they are the, I would say, most important PKI providers in Sweden. And we were happy that we teamed up with them. So what we do, it should be available in the offerings which our industry, Swedish industry, is offering to our communes and to the world as well. And this project was endorsed by many big players. You can see here. I'll skip this slide. This explains how we do this. But this is the output. What our industrial partners say about SICS and this project. That Swedish research project CBOT has solved one of the toughest IoT security problems, and it's not wrong to say this, because this enables you to use bank ID-like things, like your digital identity in a device. The strongest security you could have. It's a government-grade security we nowadays use based on PKI very quickly. And this is the Kentucky operating system. At SICS, we are mostly interested in resource-constrained sites. So everything I mentioned, it's implemented in the Kentucky operating system and released in open source. Very, very quickly, I'll take 1 more minute. I can see I'm very, very late. But this is something which is coming, and this is our bread and butter nowadays, and it should be your bread and butter nowadays, and it's extremely important to do this because it's mandated by law now. 2/3 IoT devices generate sensitive data. New regulations called GDPRs, they are coming May 25th, 2018. If you don't comply, you have to pay 4% of your global profit, or 20 million. These are the main pillars. But as a head of security lab, how do we ensure, how can we facilitate you through digital guarantees that your product services are GDPR enforced? We are not social scientists, so we are not going to give you some advice on this. But let's say privacy by design, how the technology can help you with this. And we are working on this. As I said, I just covered one small piece here. There's a lot more to do, and we have done a lot. There are a number of demos upstairs. You must go there and talk to the actual researchers, the people behind all these technologies. And thank you very much. And don't miss this as well.
Thank you very much, Shahid. You started up by saying that security is a showstopper. I don't agree. Do you agree?
Kind of.
You do? Okay.
But if you do the right technologies, I go back here. Cloud. You know, the enabler for IoT, for AI and deep learning and is cloud. You can do it because you have an enormous processing power offered by a cloud. But cloud is an external entity, and it's your personal data. You give your data to an external entity. How do you trust that cloud? And we are trying to solve this question, that you run your personal data in a cloud environment without trusting the cloud, and how you can do that. So, yes, I mean, it's a showstopper if you don't agree with me and don't use the technologies which somehow are there or being used. Of course, there's always a drift between security and convenience. And this will stay. I mean, it will never, you cannot not achieve 100% convenience with 100% security.
No.
Yeah. So the trade-off is important.
Yeah.
And definitely we are working on this as well.
Oh, that's great. And as you hear, you can, I think you have a lot more to say, so please grab Shahid also upstairs then later today. And now, Shahid, what kind of impact are you doing with?
The social impact.
Yeah, social impact.
This was red, I guess, the heart.
Oh, yeah.
Yes.
Yeah.
Okay, so then it's time to introduce, thank you, Shahid.
Thank you.
So it's time to introduce the next speaker, Elina Vartiainen. She's a senior researcher from SICS West Eros. She is a PhD from Aalto, and she has experience both from Nokia and ABB, so it's very interesting. And she is working to make the industry beautiful. This will be very interesting. The title is Visualizing Industry, Making Industry More Attractive.
Thank you. Great to be here. I'm a newbie at SICS, so it's great to be here at the first time, but I find it a very exciting day. So I will talk about visualizing industry, and it's important. The point of that one is that we can show information to the people who are making important decisions in industry, so that they can make well-informed decisions about functions that serve all of us. But I will show two examples first that are not from industry, but are from something I think that touched all of us last year. And they've been already mentioned today, so there's nothing new. But it's a new way of looking at it. So if we look at Brexit, and quite many of us maybe thought that it was quite surprising that it happened. But there's a research group in England that was visualizing retweets about Brexit before the elections. And you can see in the green color, they are showing the group that was against Brexit, and purple is the one that is supporting Brexit. And also the usernames of the Twitter accounts are visualized there with the text. And the bigger the text is, the more influential that user is. and that is measured by number of followers, retweets, mentions, and so on. So you can see there's a lot of influential people in the group that was against Brexit, and this group is usually very visible in the media. So when we read the newspapers and look at news, that was maybe the picture that we got about these elections. It was these people visible in the media. But you can see the Brexit group that was supporting Brexit was very active. That was happening a lot, but not so many influential people that were visible to us in the media. So that's why maybe we got the perception beforehand that the Brexit wasn't going to happen. And the same they could show, perhaps, happening in the US elections. So here you can see the Clinton group with the green color, a lot of the influential people here again visible in the media, and the Trump group that is not so much this establishment people, but a lot of action, a lot of noise going on. But that wasn't visible to us when we were reading newspapers and looking at the news. So if we take this kind of thinking to industry, here are two operators sitting at Mälarenergi, which is a heat power plant in Västerås. And they are basically responsible that we have heat in our homes, we have hot water, and of course all the important functions in Västerås, like the hospital and the schools and all the businesses, they also have hot water to run their operations. So these guys have a lot of responsibility. And how do they do it? They look at those complicated looking screens. We can have a bit zoom in. And this is a screen of a process graphics that they look at. It's basically giving information how the process is going. And then this part of the screen is showing then what temperature they should send to the city. What would be the optimal that we would be happy in our homes and live in a comfortable life. And they, of course, get some guidance. They have the big screen in the back of their heads showing like the temperature values, that this is probably a good number that they should steer this temperature against. But what is missing here is actually the city. I mean, what is the weather like in Västerås? There are many microclimates in Västerås. Different parts of the city can have different temperatures. They don't see actually how warm the water is in different parts of the city. Are we happy there? Do we have hot shower? And so on. Little information they get, but not everything. So they are making decisions like we were about Brexit and US elections, that they don't have this overall view of what is happening, but they have their assumption. They have, of course, a lot of experience that they have gathered during the years that they were working there. But I think we could support them a lot better by giving them more data, what is happening in the city, actually. And there is a lot of work done in this area. This is a visualization in New York, where they have visualized all the energy consumption in a building level. So it's pretty interesting to see how Manhattan here, for example, it's very much using a lot of energy. And this gives a good overview of what is happening in the city, not only for the people who provide the energy, but also to the citizens. So this is what we are doing in SICS Västerås. So we are helping with the operators to give them the overview of what is going on in the city. And of course, this is not just to visualize the information. We have to gather it, we have to analyze it, we have to run some machine learning on it, and so on. So we have a group of different competencies that are doing this. So we are gathering the data, our machine learning experts are developing the algorithms to run behind this, and so on. And I think we will be able to provide this tool to the operators so they can play with the data, they can see the situation, they have an overview, and they can make better decisions of how the city should be provided with hot water. And this is another situation in industry that we could help, where we could visualize more information. It's my colleague in the white helmet, Petter, who's maybe here somewhere also. He was summer working at Stora Enso. And here he is opening a valve in this factory. And, but he doesn't have much information, like what happens when he actually does it. What happens to the process? Is it okay? Is it safe to do it? But he is very brave, so he's doing it anyway. So we thought that here is also an opportunity, and augmented reality was already mentioned. So we developed a prototype together with ABB, and we will work it together with Stora Enso to see how it could work in their environment. Let's look at the video. With sound. But sound.
Sorry.
my Alvaro, who has made the video, he has a very nice Spanish accent, so I don't want you to miss him to tell the story. Let's hear.
System when they are working in the factory floor. They can only access this information while they are in the control room. Holographic is a research project that aims at exploring how mixed reality technology can be used in process industry to improve personnel's access to information and therefore improve the personal safety and way of working. Today, operators and factory personnel don't have access to key information on the control system when they are working in the factory floor. They can only access this information while they are in the control room. That is why they normally prepare beforehand by printing the values of the machinery before going on a factory tour. The idea of the project was to develop a prototype on Microsoft HoloLens to enable factory personnel to see the information available on the control system on top of the physical equipment. The prototype visualizes information about real-time values, trends, maintenance issues, and instruction videos for assistance. In the case of this motor, the operator sees that the temperature values are above the normal, so he decides to check the heat map visualization of the motor. He can now see which parts of the motor are more heated in case further revision is needed or maintenance should be scheduled. Once the operator checks that the motor is working properly, he continues towards the iron tanks. He is able to see all the information from the control system displayed on top of the iron tanks. The operator glances at the pressure values and concludes that no further revision is needed for today. As the tour is concluded, the prototype shows the route for evacuation exit that leads to the factory floor. In an emergency situation, this could be used as a safety mechanism, in which the application could guide to the nearest evacuation point. But in this case, as there are no alarms, the operator can safely go back to the control room and finish his tour around the factory equipment.
Alvaro is showing this demo in the poster session, so I hope you go and try it out. So it's pretty nice. So thanks a lot. I hope I was able to inspire you that there's a lot to do. I think digitalization is a lot about just giving the overview to people so that they can make better decisions. So thanks a lot.
Question from the audience? Over there.
I couldn't help seeing some zombie-like movements in the way he was walking. Have you done any research how people behave using this overlay visual technique, how they differ in the way they proceed?
That is a good question. And that is the next step that we are trying to achieve, is to work with Stora Enso and their operators, so they can really try the glasses on. And you can see that it's not very easy to have the helmet, for example, on top of it. And when Alvaro was having this on maybe 2 minutes, it's like nose and the ears and everything was aching. So it's not really there, the equipment. But it's fun to try the technology.
More questions? Oh, there is one question.
Just wondering how much runtime reaction you are considering for your system. I mean, it looks like a showing system presenting some data that are coming from statistics, but I'm wondering if you are considering also a runtime reaction on the real system, so measuring really the data and provide back in runtime any type of reaction.
You mean controlling the process? Yeah. I think that is possible because you can do it already on mobile devices. So you can access the control system and change the values. So I think it's absolutely possible. So, but we haven't implemented it yet like that.
Or are you going to try any other device?
Sure, but we try to work from the user needs. So if we find some need that matches with some technology, then we are.
Yeah, I was thinking about the magical wands or something like that.
Sure.
Okay, then the question is back to sustainability.
Yeah.
Where are you in the sustainability world? Economical, social, or green?
It's green because we are helping the operators to be more sustainable in their work and also being more economic that we can save on the fuel and so on. There we go.
Yes,
But
you
yeah. Okay.
don't forget the social. I was expecting social, so it was the best explanation today. Hand the prize.
Okay, thank you. So now the time is for the last speaker for today, and here we have Martin Mileros.
Just take some water.
Oh yes, yes. And Martin is working as a Chief Digital Officer in SICS East, which is in Linköping. And he is also a person that has, what we say in Sweden, a lot of irons in the fire. So he's doing a lot of, he's managing, I think, 6 different organizations and companies. And,
I'm involved.
Yeah, involved in, yeah. So, but now you will talk about co-creation, open innovation, value creation, and intangible assets.
Yes.
So please.
Okay. Thank you for inviting me. Let's see today's subjects. I would like to start by making an apologize. I went here in a suit, but I didn't feel so comfortable, so I actually went down to the mall and bought a hoodie. And I just want to check if that's okay with you. So, thank you. And actually, this is what co-creation is about, because it's involving people and involving the crowd and get input on what you wear and what you do. And here's actually a description from the net of open co-creation. And the important thing here is that you cannot rely on your own ideas and your own innovation. You need output from the crowd, from the customers. We've heard Google Glasses before. They start in a small group and they take input, and that's very, very important in the future. Here's just a page. There are different platforms. I think there are some other platforms. Facebook have one, and one is called Wild Ideas. And you can actually see, if you're a company, you can put things in this web page, a platform for open innovation and co-creation. And you can ask questions or put challenges. Perhaps you might be wondering, what could you code with a drone? And you want input from the crowd. Then if you click, you get a lot of input. I showed one of them, what you can code with a drone. You can actually have kind of different ideas, what you can do with it. Here's one that can say, we can windsurf with a drone. So we get a lot of input, because it's, as I said, very important to get the public's opinion in this part. We also have a project, if I relate to RISE and SICS in Linköping, we digitize Swedish industry. And we actually work with co-creation with coaches which are digitizing the companies. They share experiences, and they come up with different ideas which all the companies can use. So my view of co-creation is involvement, to use diversity, use your networks, and if you like, also use the platforms. So if you would like to co-create with RISE, I can also recommend you to check out this association, ICT Sweden. It's from the industry in ICT area, which are giving input and co-create. And if we move on to open innovation, here's also a very long description. I don't want you to read it. But the main important thing here is that you cannot rely on your own research. You cannot invent everything in your company. As we heard before, you need to buy new solutions from other companies, small, the niche companies. But you also need to realize things that you have in your own company. It could be patents, ideas that can come in use in society. So open innovation is kind of getting and knowing what you would like to get out. And this session here will be a bit disruptive. Right now, we'll do a small experiment I would like to co-create with you, if that's okay. I have also a question. How many of you have been doing co-creation before? Can you raise your hands? Not so many. I need this for my research. Okay.
All open source projects do co-creation.
Yeah. That's perfect. And there are two things we need when we're going to do innovations and co-creation. Can you think of what I'm looking for? Here's one thing. Actually, in society, we're so automated, just acting on emails, replying, so we forget to think. We don't think enough. Here's some things that you maybe do. I don't know if you throw your milk away at the middle of the night when it's expiring. And you need to consider if you're actually in charge of your actions. So to do innovation and co-creation, we need thinking. But we also need one more thing. We also need to reboot our brains. Because you maybe heard of it. Some companies, they use 20% of the time to do something else. You cannot work with your ordinary duties. And why is that? Is it to get new innovations? No. Every Friday, when people come to work, they need to actually think, what shall I do today? So actually, they are rebooting their brain each week to start thinking again. So I would like us to reboot our brains so we can start this session with co-creation and innovations. But we also need disruption. We need to be disruptive. Because in the world today, normal things aren't interesting. We need new solutions, disruptive solutions, and we need a new thinking. So my question to you here is, how can we become more disruptive? Any suggestions? I can give you a disruptive suggestion. We could check the next slide. And actually, you get a lot of help by questioning everything. I was at the bathroom here before, and I questioned, I'm always so mad at this toilet paper. You never know which way it should go. So why cannot the producers of the disposer just put a sign, here's the end of the paper, so you know which one. You need to roll it, and I don't know if you have the same problem, but I'm getting very annoyed with this. And actually, if you look at home, then you have traditional things and solutions that are very old. And if you try to, I give you 3 clues. I found this old tradition solution I had at home. And for 3 points, can anyone guess what it is? No? I give you one more clue. It's very old, 400 years. It's a solution we still have at home. No, one more. This is the worst one. We get our information from a 400-year-old solution. I think really we should need something about this. And the answer? Yes. The mailbox. Yeah. Should it look like this? My bills and my newspaper is digital. Why should I need a mailbox? And how can we? Yeah, now we're starting to create. Yes, very co-creative here. Any more ideas here? What can we use the mailbox for? I have some help on the next slide, but I would like you to think. Use your disruption. Perfect. Yeah. Maybe we can use it to receive or send packages. You know, the shared economy, circulating economy. Can we deliver packages? Or maybe daily fresh food. Right now you have a very long way for the food to come to your place, but maybe it could be,
yeah, this is a dipper type, like this. Or maybe it should look like this. If you're a student, perhaps you would like a mailbox like this. So, yeah, so I will leave this to you to figure out. And let's move to my last session. And who is owning your ideas right now? We had some suggestions. I can take this and start my company, and I'm be very happy to do this. Any suggestions? Who owns your ideas now? Everybody. Yes, everybody. That's very good. So actually, if you don't know the rules, you lose. You need to put attention on agreements, on terms. When you're going to these public platforms, you need to actually look, what does it say? What's happening with my inventions? We have co-projects with scientists. What happens if we have patents or inventions? How shall it be shared? And why is this important? Because you share more and more values outside your company, outside your project. This is becoming more and more important in the shared and the co-creation economy, social. And you also need a strategy. You need to actually put a strategy, what to protect and what to make public. That's the first thing you should do. And here are some things you can think of. Actually, data is so valuable right now. Ingrid said here it's more valuable than oil. And you can just see Google and Facebook and all these companies, they aren't producing any data. They're using your data. So as a citizen, you're actually giving away enormous values. But as a company, you can gain a lot. So I just want to mention an example at RISE here, where we made a co-creation and started a company, a spin-off within IP, which is co-owned by RISE, Acreo, the scientists, and Linköping University. I leave you with 3 small reminders here. Get involved, question everything, and get the IPR strategy. And don't forget to be active. Thank you.
Thank you, Nicklas. Do we have any question?
I have a question. Yes. I was thinking about one of the slides you said, what should we make public and what should we protect?
Yes.
But I think there is missing one piece. What should we keep a secret?
Yes.
Because if you protect, you make it public. Because if you take a patent, it's public.
Yeah, regarding to patents, you really need to think, because if you're patenting, then it's public. And if you have like Coca-Cola, they don't have a patent, but some things you need to keep a secret. But the most important thing that you know, what should you keep a secret and what can go public. So the distinguishing between those two are very important.
Good. Another question.
SICS is now part of RISE, so you have access to a lot of other institutes who are connected to a lot many more industries than traditionally. Has this resulted in open innovation for you?
Yes, actually, I think what we succeeded with RISE is that the wall, the old Berlin Wall, has fallen. And I can see more collaborations between the different divisions and parts and the companies. And I think that's key. I think that's the future. And yes, it's happening. I can assure you that. And also in society, it's strengthening us very much.
I agree. It's happening.
Yes.
And I was also having, we have some good news because this is about, again, about IPR and patents. It's quite a tricky question. So the good news is that you are going to look further into that. Yes.
I'm not a researcher, actually. I have 1 foot in industry and 1 foot in the academia. Iron in the fire. And actually, I'm attending to do some research about copyright. I think the copyright doesn't work in the digital world. We have patents, we have copyrights, design patents, and brands. Sorry. And these 4 are created in the physical world. Now we have the digital world. And we try to adapt these 4 things in the digital world, but it doesn't work. So you actually need, as I said with the mailbox, these things are the mailbox. They really need to be taken care of in the digital world.
That's great, and we're looking forward to follow you
Yeah.
in your
Thanks.
trip there. Okay, so now the question is,
Yes.
where do you make your impact?
I choose the red one, and I would like to motivate it
Yes.
with, I think we put too much effort on the numbers. We have the GMP, and we see if the society goes well, but I think we should care more about well-being, because if we produce 50% increased GDP, and it comes from the hospital, I'm not sure if the people are feeling so much better. So I think you should be happy going to work, have a happy life, and try to do more well-being. So, the red one.
Good, thank you very much. So now we welcome Ingrid back on stage. So Ingrid, we will have a microphone on you. Yeah. Good.
Here we are.
So are you happy about the day so far?
I think it's amazing. I feel proud about what we're doing, and I think what we have seen today is all these different aspects. And that's really what I wanted to start with like sustainability. We need all these aspects. We need the security. Even what you say, you're a game spoiler. And we need the next step of AI. And we need co-creation to get things done. And I get the feeling that we have been able to show that to you, that we really want to do. So, yeah, I'm happy.
Good. And you have to put some balls here as well, I think.
Yeah, I think you heard what I want to do. I really see that we must increase this GDP so that we could do all good things, so we could take care about it. We need the money. We love environmental, and think about my mom and all others. I want this the heart.
Good. So, thank you.
So, should we say welcome to the next? We have some slides what's happening after this.
Yes.
Should we see here if we could have some help? So we will have lunch now, and after that I hope all of you could come and look at what we're doing. We have 91 posters up there. Think of that, 91. You will be busy this afternoon.
Next year is 100.
Visiting all our researchers. And this is just some pictures, what you can see. First one is a work that we're doing together with Scania. With all these new sensors and all this what's happening, how could we really secure the testing? There we can learn about that. You can learn more about the drones and the test bed we have. And I just could mention, in this afternoon, if you listen to Studio 8, then you can listen even more about these drones and learn even more. And we have posted around how should we build the infrastructure for all these millions of IoTs. How could we build our research with the machine learning system together to realize that we can take the next step to build this system of systems of millions of sensors. And just continues like this. So enjoy. And thank you for our Helena and Tom, for our moderators.
Thank you. So lunch will be served at floor 6. So you're most welcome up there, all of you.